Hi, my name is Niman Bhatt and I welcome you to this video tutorial which is about GNS3, which is a network simulator used to design networks. So this is the part 8th of this video tutorial in which I try to teach you networking. In the previous tutorial we have already talked about how we could map host names to the IP addresses, and also we talked about DNS server and its configuration. In this video tutorial, we are going to talk about ping, extended ping. Basically, we use ping to check the accessibility and the connectivity between the networks and to see if the connection is made and if the data is transferred or not. But with this extended ping option, we can check the connectivity of this network, and also we can modify the parameters also. This ping, extended ping, one of the most important features of this extended ping is to it helps us to define the source address. We can choose any IP address as the source address. So what is this ping command used for? Ping is the command which is basically used to test the accessibility of these devices. The Cisco iOS devices have already, it supports this ping command, and we can modify many parameters with the use of this ping command. As you can see here, I have already developed a network. I'm going to show you. This is router 1, this is router 2, router 3, and router 4. I have connected 4 routers, and to these 4 routers I have connected 4 switches. That is switch 1, switch 2, switch 3, and switch 4. After this, what we are going to do is first we have to configure IP addresses for these 4 routers, which I have already taught you in the previous tutorial. Suppose R1 and R2, we are going to keep these routers in network 1, and R1 and R4 in network 2, and R2 and R3 in network 3. Let's do the IP addressing first before we can move on and check this extended ping. I'll open router 1, console of router 1. Okay, I'll go into the configuration mode of router 1. Press enter. Okay, now let's see what ports it is connected to. Router 1 is connected to through serial 0/1 to R2, and serial 0/0 to R4. Let's first configure this R1, that is serial 0/1 port. I'll open the command line again. Let's move into interface serial 0/1. Press enter. Now let's do the IP addressing. As you can see, I'm assigning an IP address to this serial port 0/1, which is 192.168.1.1. Now I'll assign a subnet mask to this port, which is 255.255.255.252, and then I'll press enter. Now, as you can see, the IP address is assigned to this port, and I'll put it on. I'll write the command no shutdown and press enter. Now I'll go back. Okay, I have configured only one port, which is this port here. Okay, now I'll try to configure this port and this port. So for that, I'll first check the ports. This is serial 0/0 port, and this is fast Ethernet 0/0 port. Okay, first I'll configure fast Ethernet 0/0 port, and then I'll configure this serial 0/0 port. Now I'll go into the interface 0/0, assign IP address to it, and the subnet mask also, and then press enter, and now shut down, enter, and exit. And now I'll try to assign IP address to another uh, port, which is fast Ethernet. I'll go into the interface, fast Ethernet 0/0, and now I'll give it the IP address, which is interface now IP address, which I'll choose as IP address 192.168.3.1, and then I'll write the subnet mask also, and then I'll write no shutdown for keeping the link on. Now I'll press exit and save all of this configuration by writing do wr. So what I've done is I have assigned IP address to 3 ports here, that is this port, and this port. Now I have to do the same with these 3 ports, that is this port, and this port, and similarly for this port and this port and this port and this port. Okay, now I'll do it for the router 2. I'll first check the ports that are fast Ethernet 0/0. It is serial port 0/1, and it's serial port 0/1. First I'll configure serial port 0/1. Okay, I'll open the console of router 2 again, go into the configuration mode, and go into the interface, serial 0/0, and press enter. Now I'll assign IP address to it, which is 192.168.1.2, and then I'll assign the subnet mask. Now I'll keep this link up. Okay, now I'll go back into the configuration mode. Okay, one port is up. Now I'll go with this fast Ethernet 0/0 and serial 0/1. Let's do fast Ethernet 0/0. Let's do fast Ethernet 0/0. For that I have to write the command I'll have to go into the interface of fast Ethernet, interface fast Ethernet 0/0, press enter, and now assign IP address 4.1 and subnet mask. Write no shutdown to keep the port up. Press exit, and now save the configuration. Okay, what I have done here so far is that I have configured router 1, the 3 ports in the router 1, and router 2 and its ports. I hope that you can configure router 4 and router 3, which has only two ports. It's easy, as I've already taught you before. Now I have to show you the extended ping. that is why I am going to show you this extended ping with the help of router 1, and what are the parameters that we can modify with this extended ping. Let's go into the console of router 1. Okay, what we have to do is we have to write the command ping, only ping in this privilege mode. Write the command ping. Okay, as you can see, this is the first parameter, which is the protocol IP. That means you can change or assign a protocol here. You can shift to any other protocol such as AppleTalk, CLNS, Novell, which are the other protocols available. By default, the protocol has been set to IP. You can change it or keep it as IP. If you want to keep it as IP, press enter. If you want to change it, then write some other protocol, for example, CLNS or any other protocol, and then press enter. Right now I'm going to keep it to IP. Okay, I'm the protocol I'm choosing here is IP. It depends on you which protocol you want to choose. After you choose the protocol, just press enter. Now you have to enter the target address. Remember, right now we're basically changing, we're learning to modify parameters with the help of this extended ping command. First, we had to do the interface IP addressing. We did that for 2 routers, and after that, I'm teaching you this extended ping. So now we're talking about the target address. Target address is the address or the host which you want to specify, which you want to ping. You have to specify an address here which you want to ping. So it can be an address or a host name which you have assigned to an IP address, or the name of the port. You can also do that. So here, say for example, I'm using the router 1. As I'm using the router 1, I have already assigned this router an address of 192.168.1.1. I'll try to ping this port here, which is 192.168.1.2. So I'll write the target address as 192.168.1.2. This is the address which I want to ping, and then I'll press enter. Okay, now the next option here, the next parameter which we can change is the repeat count parameter. So by this repeat count, we mean that we have to specify number of ping packets. Okay, the packets that we want to that will be sent to the destination, that is the target address which we have chosen. So we can change this. This is by default set at 5. We can change it to 10. Okay, or keep it to 5, whatever you like, whatever the count you want to choose. It can be 5, 10, 15, or whatever it is. Right now I'm going to check and keep it as 5, and then I'll press enter. Now the next parameter which we want to change is the datagram size. Now what is this datagram? What this datagram size means that we have to specify the size of ping packets in bytes. Okay, as you can see, what is written here is the datagram size is 100. That means the size of the ping packets is 100 bytes. We can change it to 110 or 150, or keep it to 100, and depends on the size we want to select, and then we can press enter. Now the next parameter which we want to choose, or which we can change, is the timeout in seconds. This is the timeout basically which we want to choose for which we want to specify the timeout which we want to specify, interval which we want to specify. By default it's set at 2 seconds, and we can change it. Okay, now after, if you want to continue it as 2 seconds, you can just press enter, or you want to change it to 3 seconds, 4 seconds, 5 seconds. It depends on you. So right now let me change it to 3 seconds, and then press enter. Okay, extended commands. This command, extended commands, gives us an option if we want to view more commands, if we want to change more parameters. If we want more parameters here, then we have to write the answer as yes. By default it's set to no, that is we won't get any extended commands if we continue as no. If we want more commands, we have to press the command, we have to write yes and then press enter. Now the source address or the interface address, which is a great benefit of this extended ping, which means that usually when we try to ping a device from router 1, this is the router 1, and when we are trying to ping this port here, the data will be sent from this port, that is serial 0/0 port. But what can we do is, with this source address we can choose any address, that is any IP address. For example, the address which I have assigned to this fast Ethernet port, which that is some address which I assigned to it earlier. We can check it. Okay, I can check from which is 3.1. The address assigned to this is 3.1, 192.168.3.1. I can check and send this. I can ping this device R2 from this address here with the help of this router only. Okay, so for that I have to change the source address, which is a greater benefit of this extended ping. What we have to do is we have to change the source address. We have to change the source address or the interface. We can also write the direct interface name. Okay, for example, if I write fast Ethernet 0/0, sorry, I'll just write the address which I have assigned to it, which is 192.168.3.1, and then I'll press enter. Now the source address of the interface is assigned, which I'm going to show you again. The source address of the interface, that is the source from where I want to send the packets, from where I want to ping, is assigned already, and the address I have wrote already as shown above. Similarly, now the next parameter is the type of service, which is the type of service is the internet service quality, if we want to choose it. Right now it is disabled, it is set to 0, and usually it is set to 0 by default also. So if you want to know, move to the next command or move to the next option, move to the next parameter, just press enter. Now the next parameter is set df bit in IP header. With this we can basically specify whether or not the don't fragment bit will be set on the ping packet. That is, if we want to fragment our ping our ping packet, yes, if we want to fragment our ping our ping packet, we have to set it as yes. It will, if we set it as yes, it will not let our ping packet to be fragmented. Otherwise it will let it to be fragmented. That is the main job of this set df bit in IP header. We can set it to no or yes. It is set to no on default. We can change it to yes by simply writing yes, or we can set it to no and then press enter. Validate reply data is set to no by default. It is used to specify whether or not we have to validate the reply data. It is set to no by default. You can change it by writing yes and changing this validation. Then press enter for the next parameter. It is the data pattern. It is basically the pattern of data which you want to use for and this is used for troubleshoot framing errors and clocking problems also. So this with this data pattern we can specify the data pattern which is set to default, and it is shown here. This is set, it is set to default as this. You can change it, depends on you if you want to change it or not. These are the parameters which we can change, and then we have to press enter. Now these lose strict record, timestamp and verbose, it is selected as none of the above. This is basically used to specify the IP header system. If you want to use any of the header among these 5, you can write the name and continue with it. These are the options available for us to use as the IP header system. Now you can modify it the way you want to, then press enter. That is the next option. The next parameter is the sweep range of sizes, which is selected as none, sorry, no. And it is used to change this size of the sweep range of sizes, change of the size of the packets which we want to choose, which we want to send. So if you want to change the size, you can change it here, and it is set to no here. You can change it to yes, depends on you. These are the parameters which we can change with the help of this extended ping. Now I'll just press enter and show you how it continues after this. It right now it is trying to send a packet to 192.168.3.1 with the different source address, and as you can see, the other parameters which I have changed here includes protocol, target IP address, repeat count, datagram size, timeout in seconds, extended command, source address, type of service, set DF, validate reply data, data pattern, and the IP headers, and the size of ranges. These are the different patterns which we can choose with this extended ping option. As I have shown you in this video tutorial so far, what I did is, what I only have interfaced two routers for, that is, I have only done IP addressing for two routers, which is R1 and R2. Please do this IP addressing for R3 and R4 router also, and then you can use this extended ping option with all the 4 routers. And if you want to use the extended ping option for any interface, you can use it. You can choose any of your interface as the source IP address and see if the connection is made with the other address or not. This was basically all from this tutorial. Thank you for being a part of this.